Hey everyone, welcome back to part 2 of lesson 8 on binomial theorem. We're going to look at example 7 now, where they say determine the constant term, which we talked about before, the term independent of x, in the expansion of 2x minus 1 over x squared to the 15. Now if you recall, we did a full expansion on that blank piece of paper, and one of our terms, the x's canceled off completely. We had x to the 4 on top and x to the 4 on the bottom. Well, here's what we're going to do to figure this out. And we won't need all this room because I do this in a different way than the workbook intended, is we're going to do one term in the expansion. We're obviously not going to do a full expansion of all 16 terms. Okay, so we put a 2x here and a negative 1 over x squared in the second set, just like we have been doing, right? Then it takes a little bit of guess and check, but typically people guess especially after they get the hang of this, they guess right on the first or possibly second try. Okay, we want to guess at what the exponents here would be, such that the resulting powers of x end up canceling off on the top and the bottom. We do know our exponents have to add up to 15, our end value, and, oh, let's not forget about that, so 15, choose something out there. And if you'll notice too, this is just x to the 1 here, and this one's x squared. So logic dictates that our exponent here would have to be twice what the exponent is here, so that this kind of balances off. So let's think about that. Two numbers that add to 15, and this one's twice that. Now let's say you can't figure it out from there. Let's just try some numbers. Let's go 8 and 7. Okay, so just focusing on the x's for the moment, this one would be x to the 1 times 8, so 8. And on the bottom here, this would be x to the 2 times 7, or 14. And since they're not the same, they would not cancel off. So we got to try something different. Okay, so if you're thinking maybe 10 and 5, see 10 is twice 5. And then if we simplify that, that'd be x to the 10. And on the bottom here would be also x to the 2 times 5, so 10. Okay, so that's what we're going to do. Just to finish this off, 15 choose, and this last number here is whatever the last number is here, so 5. Okay, and we can get that number on the calculator. I think it's 3003, if I recall. And then here, 2 to the exponent 10 on the calculator would be 1024. Negative 1 to the 5 is going to be negative 1 over x to the 10. Good. Now we keep going with simplifying that. As I mentioned, our x to the 10s will cancel, and then you multiply all three of those numbers together, and we would have what our constant term would be. So let's do that and get that number. Okay, so if we multiply all three of those numbers together, 3003, 1024 times negative 1, we should have negative 30. Lost the number. Let's bring that back up. 3075072. 75072. And there we go. That should be our constant term. Now, if they asked which term is the constant term, like the fourth term, fifth term, whatever, again, it's this number here, the k value, because it's tk plus 1, which we haven't talked about yet, but the k value, which is 5 plus 1, so it would be the sixth term, okay, if that did come up. All right, good. Let's take a look at some examples from the beginning part. Okay, so we flipped backwards to this page where it has the general term of the expansion, still in lesson 8. And this is on your formula sheet actually for the diploma, so you'll be able to access that, and that's this formula here. And what that refers to, and if you'll notice, it's really what we've been doing, right? And choose k, and then whatever's in the first position here, x, to the n minus k, and then whatever's in the second position to the k, and then that gives us a certain position of a term. So we're going to put that formula to work on example number 1. And I'm going to write it down first, actually. tk plus 1 equals n choose k, x to the n minus k, y to the k. Okay, and they're asking us for the fifth term. So what that means is so we're looking for t5. So just write t5. That means we're looking for the fifth term. If you compare that to the formula, that would mean that k plus 1 would have to be 5, which means k would equal 4, right? 4 plus 1 is 5. And then we know our n is the exponent on the original thing, so n is equal to 8. All right, we are ready to go to sub things in. N is 8, k is 4, so 8 choose 4. Now x isn't always x. X is whatever is in the first position. In this case, it is x. So x to the n minus k, 8 minus 4, so that would be 4. Y to the k, which is 4. Okay, and we almost have it. We just want to, on the calculator, get 8 choose 4, and then we would have our fifth term. So let's do that. Okay, so we should have gotten 70. So our fifth term for that expansion would be 70 x to the 4, y to the 4. Okay, let's try this one here, the middle term. A little bit trickier on the middle term because they didn't tell us the position of the term. So what we have to do is look at our exponent, our n value. So if the exponent is a 10, that tells us there are 11 terms. So which term would be the middle term? Well, a quick way to do that when that number is pretty big is go 11 divided by 2, which is 5.5, and then round up. So it's the sixth term. Sixth term. Okay, so we're looking for T6. Now let's write the formula down above that again, because I find that works pretty well. Then you can compare to find the k value. Okay, so it would be, if you compare here, we have k plus 1 and we have 6. So in order for that to be equal, k must have been 5. N, which is our exponent, was equal to 10. So now if we sub things into our formula, we have 10 choose 5. X is not x in this case, it's a. So it would be a to the 10 minus 5, so 5. And y is not y, it's b, so b to the 5, the k value. And there we go. If we simplify that, get a number for 10 choose 5, and then we'd have a to the 5th, b to the 5th. Okay, so grab the calculators. Let's do that. Okay, so we should have gotten 252, a to the 5th, b to the 5th. Awesome. Okay, now example 2 we're not going to do because we did a couple full expansions using on that blank piece of paper. But what we'll do is look at this one. Susan was determining the fourth term of 2x minus 5 to the 6. Okay, so we are going to use, okay, so they've got the formula here, just like we would write down. We want the fourth term, so if you compare that, that would mean that k would have to equal 3. Okay, looking at your n is your original exponent, so n is equal to 6. So we would have 6 choose 3. Instead of x this time, though, we have 2x. So you would write 2x in brackets, and then n minus k, so 6 minus 3, and then negative 5, our second term in the binomial, to the k, which is 3. Good. So now all we have to do is simplify this. Let's get 6 choose 3, and you guys go ahead and simplify that and see if you can get what that term would be, okay? So pause your video. Okay, so we should have gotten that the fourth term was negative 20,000 x cubed. So now looking at our last example for this lesson, class example number 4, determine the fifth term of 3x minus 2y to the 7th. Okay, so again, I would write down the formula, tk plus 1 equals n choose k, x to the n minus k, y to the k, and we're looking for the fifth term. Okay, so I think you guys can handle this one. Why don't you try it and pause your video and we'll check back and see if we've got the same answer. All right, so simplifying that, we should have gotten negative 6,048 x squared y to the 5th. And yeah, just make sure you keep brackets around these things so you don't start thinking that it's 9 minus 32 or something like that. And also make sure this exponent applies to each term inside. In this case, x wasn't x, it was 3x, and our y was now negative 2y. The sign goes with it. Okay, so hopefully you got the same value, and if not, or the same term, and if not, please check with me in class tomorrow and we can take a look at that one. So good job, everyone. Thanks for listening, and hopefully lesson 8 goes well for you. Adios.